Hello and welcome to our presentation. I'm Bryce Anderson and I'm working with Samuel Minear, and this is a recording for the BYU GIS Programming class in the winter of 2016. Today we're going to be talking a little bit about some Python scripting that can be used to automate some geoprocessing functions. We're first going to talk about our problem definition, our proposed solution, and then we're going to review the methodology and implementation of our solution using Python and ArcMap. And then we're going to check out a couple results and see how we did. The problem that was presented was to create the least cost path to install a railroad between two major cities, in this case Salt Lake City and Las Vegas, Nevada. In order to do this, we needed to take into consideration many different parameters that would affect the cost of the rail, such as elevations, slopes, existing roads and railroads, and who owned the land. The first step to solving this problem was to find the input data sources that we needed to represent the elevation, slope, and land ownership. After gathering the data that was necessary, we prepared a pre-processing tool to convert the data into a raster format that could be used by geoprocessing tools within ArcMap to then go into a least cost path analysis, which we could also script in Python using geoprocessing tools in order to prepare the final least cost path analysis for multiple different scenarios within the same script. And now I'm going to give it over to Sam and let him talk a little bit about how we found our data and prepared it for use.
As Bryce mentioned, the first step was to find data. When we were looking at the individual websites for data sources, we realized it would be hard to find continuous data. We found the continuous data on the USGS website. First, we found a database, the small scale data, which had our shapefiles that we needed for roads, railroads, federal lands, Indian reservations, cities, streams, and water bodies. While there was other data sets available on there, we decided to stick with just these parameters for this analysis. For the elevation data, that came in different tiles, and we needed to put those tiles together using the mosaic to new raster tool in ArcMap. And also before we started using our automation tool, we knew that we needed to do a little bit of data manipulation beforehand. For example, we took the elevation data, calculated the slope in ArcMap, and reclassified those two data sets for this analysis. We also were able to extract the military and national forest land from the federal land database and to be able to separate those out so we could have a distinction between those two land areas. So the second part was to be able to use this intermediate data processing, and we realized that each of our point, polygon, and polyline features needed to be converted to rasters and reclassified for the least cost path analysis. We figured that using the reclassification could help us identify the presence or absence of a given feature. And so we were able to use this for the Python scripts, as we found that it was a repetitive process to be done again and again. So on this next slide, you can see an example of the national forest or sensitive lands being converted to a raster and then being reclassified to identify the absence or presence of a given feature, the 1 indicating the absence of national forest, a 2 indicating the presence of a national forest. So let's take a look at the script that was used as part of this analysis process. As you can see, there's a little bit of metadata describing what this script does and some of the runtimes that we were able to have before in the past. The first thing that's done is to call the ArcPy and operating system module. This is done so that this Python script could communicate with ArcMap and execute the different tools and operations. We set the environment to overwrite the existing output files so that we didn't have conflicts or error messages during this process. The next thing that we did is that we made sure that we had the spatial license to be able to use the spatial analysis tools in ArcMap. You could see this function called ArcPy get parameter as text. We used this to communicate with the interface in ArcMap, as we'll see in just a minute, to see what input data sets we needed to bring into our analysis. For example, folder, cell size, the study extent, and the different features listed previously. We'll see an example of selecting those in ArcMap. When we defined our local variables, what we did is that we wanted our output rasters files to go to a specific area after they were reclassed. So we were able to designate that by concatenating the folder path and the name of the file we wanted to be the output. Something else in the script that we used was functions. These functions helped with repetitive commands that we used in ArcMap to process the data, which was very helpful to be able to call the functions below to come back here. For example, you see this Reclassify features function, which was able to take an input raster and the name of the output raster, and it was able to convert the raster properly, as we saw in the previous slide. We created the function for Polygon to raster conversion and Polyline to raster conversion also. So the rest of the script describes the process of analyzing the features. The cities had to be done specifically with a different process because we were trying to create multiple ring buffers. Everything else you can see with the Indian Reservation, the National Forest Sensitive Lands, and the military land, we were able to call the functions prepared above, Polygon to raster, and then be able to do Reclassify features function. So now that we've taken a look at the script, let's go ahead and run the script. Jump into ArcMap. So here you can see all of our raw data. You can see the different land boundaries, you can see the railroads, you can see the roads, you can see the cities. It just looks like a mess of data. We're going to use our tool to help make sense of some of this mess. Before I run the tool, I'm going to hide some of these features to turn them off, just to have a clear view of our map. So we open our toolbox, we go to our data preparation script. In this script, we created help text to be able to guide the user through the process of using our tool. Right now I'm going to designate an output folder for our rasters to go. In this case, we usually have the default cell size set, but we're going to make it a little bit larger cell size so that it can run a little bit faster for this example. And our study extent, we prepared over on the map to cover Las Vegas and Salt Lake City. This tool allows the work to be done with any other cities as long as the data is prepared for the area. So here you can see that the first thing that's being done is the city's shapefile is being worked on, and it takes a little bit to run through, especially something that we found is that the streams data set, it was a larger file, it had a lot more features to run through, and that took a lot longer. But we should be able to see that this tool should run in about 7 or 8 minutes. So we're going to pause real fast and come back once it's all done.
Alright, we can see now that the script is fully completed. It took about 7 minutes to run the script in this example, and now let's look and just check out one of these reclassified rasters that is prepared that shows the roads file, and so we can see here all of the roads that are in our study boundaries. Now we can jump back over here and see what else is coming up. The next step is taking all of these rasters which have been reclassified and doing the final least cost path analysis, which is going to include geoprocessing tools, including a raster calculator or map algebra, and then some least cost path analysis using spatial analyst tools in ArcMap. The raster calculator, we have shown kind of what it'll do is we'll take our feature values from our rasters, multiply them by a parameter input, and then sum them all up, and we'll use that to determine costs to travel. So we can take a quick look at the input CSV that's required. So this CSV can be prepared however anyone wants to, and includes a scenario name and then input integers that represent the weight given to each parameter for each separate scenario. And using this input CSV, we're going to go ahead and let's go take a look at the script and how it's going to apply to this. So here's our final script. We want to mention that both of our software, both of our scripts are licensed under the MIT license and freely available for any use. Again, we're going to go import a couple modules that are necessary, set some environment and primary document variables for Python. The first step that we have, our first function, is to read in our CSV file, read in our parameters. And so this function here is going to be used to read in our files to a list that Python will be able to recognize and then later access and use. We'll again see in our user interface several different parameters that need to be input that Python is then going to read and show us. And so here we just have a reading in each of our parameters and reading in our CSV to a list. The next definitions we have are for some intermediate data sets that are required for the geoprocessing tools. And again, I mentioned that it's necessary to have the spatial analyst tool set in order to use these, as the cost distance and cost path tools require spatial analyst tools. So now we're in our for loop is the meat of what our analysis is doing, is that we, for each different scenario proposed, we will prepare using map algebra or a raster calculator a raster of the cost to travel through each segment of the raster. We'll input that as an argument in a cost distance function, which will then use outputs from the cost distance function and the cost path function in ArcMap, which will then result in the least cost path to travel between Salt Lake and Las Vegas. That path will then convert to a polyline for ease of access as a shapefile that will easily be seen. Then we're going to go through, we're going to update text on our layout view for each element so that we can see what our input parameters were for each scenario, print it to a PDF, and then we're going to close those PDFs and the script will be finished. So now going back here, let's go ahead and jump into ArcMap and see how the script runs. And so we're going to come here to our layout view, which has been set up and prepared for us to see the different parameters that are being input, scenario name, and to represent our least cost path between Salt Lake and Las Vegas. When we come over here and open our tool, we're going to be faced with these input parameters, which include a working folder where we want everything to save, a place for our PDFs to save when we're done, and then also our input CSV that we looked at earlier. And so using each of these as an input parameter, as well as each of the reclassified raster layers, a beginning point and ending point, we're going to go ahead and run this and see how it does. We can see it read the CSV file very fast into a Python list for access, and is currently analyzing the first of 19 scenarios. So we'll let this run and come back when it's finished.
As we can see, the script finished in about 4 minutes. You can see prompts from the script document window to see as each scenario was being analyzed. And this is a great result. We are happy to see that this is working, and we know it can work for you too. So in the beginning, we wanted to find a least cost path between two major cities. In this case, we looked at Salt Lake City, Utah, and Las Vegas, Nevada. The end result is we wanted to see these scenarios in an easy-to-view fashion. This is done using multiple PDFs as they are put together, and then we can compare the analysis side by side or back to back. So let's take a look at the results. Here in the Explorer window, you can see the different maps that came up. So you can see the individual map numbers, or you can look at the map that is put all together. When I put it in this view, you can see the name at the top, the name and the number at the top, and you can see the parameter multipliers. As I scroll through, you can see the path changing for the least cost path, and you can see the parameter multipliers changing also at the bottom. This makes it valuable for comparing side to side and scenarios and to determine which path is the best. This analysis can be rerun, changing the parameter multipliers and seeing if there are different scenarios that should be investigated. And that's the conclusion of our presentation. Thank you for watching us, and have a great day.